Hello, YouTube. What's up, guys? Alright, so today we're going to talk about the most interesting numbers in math. And these are the top 5 that I've chosen, I've kind of been inspired by, and I know that a lot of mathematicians talk about and still talk about today, obviously. So let's take a look. First number, pi. So pi is the ratio of the circumference of a circle to its diameter, and you are mostly familiar with 3.14 as pi, but this number goes on forever and does not repeat itself. I made a video on pi before. It talks about how you can convert numbers into letters, and you'll have every word in the dictionary, and you can have every word, letter, syllable, whatever. You can add everything from pi, pretty much. Like if it's converted into letters, like everything comes from this simple circle. Pi is pretty cool. It's in trig a lot. It talks about degrees, radians, and stuff like that. But think how awesome that is. It's an infinite number. It goes on forever. That's just crazy. All through a ratio. Next we have is e. E stands for exponential, actually. And what's interesting about e, if you take calculus, but first e, 2.71828, and it goes on forever as well. And this is where it actually comes from. If you take the sum of all the numbers of 1 over n factorial is like, if you had 3 factorial, that'd be 3 times 2 times 1. And if you add up all the fractions, so you'd start with 1/2 and then 1/6, etc. When you add all those up, you get a sum that's actually this number here, and it goes on for a while too. The also interesting thing is that the derivative of an exponential function is the exponential function. That's pretty hard to fathom, and this is obviously what the graph an exponential function looks like. So there's e for you. 0. Whenever you multiply by 0, divide, add, or subtract, 0 means really nothing, right? 0 over 0 is undefined. You can't divide by 0. A number to a power of 0 is 1, and we'll get to that in a second. But 0 also was used as a placeholder for like decimal points, to represent very small things or very big things too. Things like that. It's just interesting what is 0 over 0, dividing by 0, or how could you represent a number with nothing, 1, and that's where we left off from here. So 1, the multiplicative identity is the most interesting case. Going back to 3, I guess 3 times itself is 3, right? Interesting. Like, how do you multiply by itself? 1. How does 1 represent itself? Dividing by a number 1. How does that represent itself? It's just an interesting number, a whole number, just solid 1. We are one individual, right? But we're made up of multiple things, so how are we one? Next up is imaginary numbers. Imaginary numbers are interesting. So this little diagram here is an imaginary clock, I guess you can call it. And what I figured out is this. Okay, so first the square root of -1 is an imaginary number. And so if you take the square of I of imaginary numbers, you would have -1. And I cubed would be -I. And I to the 4th would just be 1. So that's interesting how you take, 4 times I, or I raised to the 4th, and you get a solid number 1 again. Things like that. Like, how do you have imaginary numbers? How can you even think about them? It's crazy. It's just, I don't know. On imaginary numbers, how do you have an imaginary number? It's weird. So to conclude, these were the numbers I chosen: pi, e, 0, 1, and I. Now, one more thing to summarize, or to add a little kick to the video here. So using Euler's method, or formula, not method. Actually, E came from Euler. Forgot to mention that. But using this formula he has, when theta is equal to pi in this formula, you get this. And check it out. 1, 2, 3, 4, 5. These are all the interesting numbers chosen in this video. How does an exponential function raised to an imaginary number times a number that goes on forever without repeating, plus the number 1, a whole number, equal nothing? Right? Isn't that crazy?